Okay, so without further ado, welcome everybody. Thank you very much for coming along. So thank you everyone. This evening, let me welcome Dr. Eric Dullin. Eric, thank you very much for coming along. Round of applause from everybody.
Thank you so much.
Am I supposed to hear at this point? Okay, hold on a second. Oko, yes, you are supposed to hear. We can all hear. Hopefully, anybody else out there, just ping me something in the chat to let me know that you can hear us. I can hear Eric, I can hear Peter and everybody else. So I'm assuming you can hear me. Okay, so my mics are all on. Everything, sound is all good. Audio is okay. Peter, thanks, very good. Yeah, all good. Okay, so in that case, if I go back, everybody could hear everybody. I say, okay, so I just check your settings to make sure that you haven't muted anything. It's really good sounds quality. Thank you very much, everybody. So going back, so welcome. Thank you very much, Eric. Now, let me just introduce Dr. Eric Dullin. So Eric is a researcher based at the Anomalous Psychophysics and Cognitive Dissonance Laboratory in France. He's a background in mechanical engineering, a PhD in software and automation. We met actually in 2017 in Athens. I remember this when Eric, and I've got these here, so I'll show you, where Eric was very kind enough to give me some of these things. He's going to show you this stuff later. It will make a lot of sense. And he presented there some very, very interesting research on telekinesis. Okay, so, and that's his topic this evening. He's going to be talking about methodology and results in macro PK experimental research. I cannot see your email address. Chat. Okay, I can only see my own messages. I will send the, okay, so my email address is, there you go. Thanks, Peter. Again, it's david.vernon. So my name there, as you can see, and then it's david.vernon at Canterbury, the wonderful historic city of Canterbury, just think Chaucer, at canterbury.ac.uk. Okay, Peter's just posted it as well, so hopefully you can see it there. So, Eric, thank you very much for coming along to talk to us this evening. Really appreciate this. It's a really interesting topic, and also, you know, it's fun to see your research being published. I noticed not only you presented this your research at the SPR conference and then the PA conference, etc., but you've recently had papers published in both JSC and the Journal of Parapsychology recently as well, in the latest one. So excellent stuff. So thank you very much. I shall hand over to you if you would like to start your presentation, and then I'll close down my camera. Just to let everybody know, when Eric switches over to his presentation, you probably won't see either of us, but that's not a bad thing. You'll see the presentation. That's the important thing. And then you'll be able to hear Eric talk. Okay? So thanks very much, Eric, for doing this.
So thank you very much for David and Peter and SPR for giving me the opportunity to talk about this work. And let's move on. I will put in the screen sharing. Okay, that works. First time. Try next. Okay. Okay, that's better.
That's good. Yep, we can see that.
That's better. So let's go. So, and also, okay, I'm sorry. Yeah, we're on that. Yes. So, yes, we are talking about macro PK experimental research. And first, we maybe talk about this word, what we mean by psychokinesis or telekinesis. So I just will come back to some wordings that are done by Ravoglis and Bansel in 2018. They say that PK is the putative ability of organisms to affect other systems, both animated and inanimated, without mediation of any known physical force or energy. That's the global picture. Today we are looking more about micro PK. So micro PK, what is it? It's to look some visible PK versus micro PK, which is more about random number generator influencing using statistics. And what we are more specifically focus on. So macro PK, I am working also in our lab on a global approach to see what's happened in macro PK since antiquity until now, and notably specifically about poltergeists and physical mediumships. But today we are focused on macro PK on spinning objects. That's the way we experiment the things. And I will come back quickly on how it comes. In the past, around 1850, there was a big move on mesmerisms, and people are starting to put some needle above the thread and look that when people approach the end, the needle was moving. And so they induced the fact that it was a vital force or bioforce or animal magnetism, and they built some apparatus to exploit this force. And the Tromelin built some what he calls motor, which was simple paper roll on it with a straw and a needle, and you take this one and you put on the top of a stand with a coin, for example, and you try to move what you call the motor. On our side, you can use that at home. So I think that's what we'll talk about with David. It's easy to test. So many people can try to use first aluminum paper, but the problem is that it's very light. Okay. Yeah, you can use more heavier paper. There is also the Egli wheel, which is a standard systems. So a little heavier, but very sensitive because of all these points. Very sensitive to the air current. Then you can move up with a more heavier systems with a paper and aluminum, which is thicker, like the one you can find in some coffee packaging. There you can find the Tromelin motors we already speak. And then you can use something we can use in the kitchen, like a ramekin, which is really heavier, because it's about 3 grams. And then you can move up the scale to try to with 10 grams with a carousel candle. And then you can move other piece like this one, which is 40 grams. You just put a stand of the carousel and you put the porcelain ball on it. And then if you want to take some fun, as some people in your teams, you take some mold and you stacked two mold, and it gives 500 grams of weight. So, but if we want to make some experiments, we want also make experiments with scientific control. We decide to use a specific target with a shape which is we didn't give too much grip to the air, so smooth and with symmetric shape. And the initial target, as David showed you, was simple cup with a plastic plug and a needle. And now we use a more standard system using the standard stem of the carousel and the same plastic cup. And you can pile up different plastic up till 1 to 9 we have done, and try to run it. So just to give you some example, where is my file? Okay, sorry. So I can show you this one, for example. Okay. So start. So this is Pierre. It's a Canadian guy, and I will not all the time he spent on it, but you can see that the target is spinning quicker, and then here we have normal speed, quicker and quicker. And this at that time we were at sorry, just coming back. It's a bit on the end. Yeah. At that time we were around 2 seconds per turn. So it's pretty quick, and you can see that if you see at the end, you can see that there is he was already taking a mask, even if it was not the COVID pandemic. So another example, for example, with very different. So this is using a portable bench we will talk about later. This is the porcelain bowl. You see that at start it's a bit difficult to balance on the stand, but it's possible. And then it takes, in this approach, we use 3 cameras, so you can really see how is the end. So this portable bench we described later with an opening here, and the target. And you can. This is the view from above, and you can see that it's starting to move very slowly. With a vertical view, you can see better. So it's very slow.
It's worth, Eric, it's really worth stressing there that the smoke that's coming into that apparatus.
Yeah, I will all explain this, David, no problem.
Good, because I think that, that's an important point.
Yeah, it's just to show the use of the different target. So, and if you look at maybe I'm a little too far. So you see the move. So the move, because it's a big inertia, the move is slower than that you can see before, but it's 40 grams. Okay. So this was another example, and the last one I will show you on this approach is the one with the 2 mold. So same thing, it's very low at start. So if you look at this at normal speed, you see that here you see it's moving, but very slowly. And then it accelerates. And then at the end, we were at this speed. Okay. So this is some examples that you can do at home too, if you want to try. No problem. I want to show you also some example where we use confined environment, and we'll discuss this later. For example, I will take this one. So we have a double here. It's a double glass jar. So we have 2 glass jars piled up, and so we are trying to move one of the psi wheel. We see it stop moving. Okay.
So in that instance, you're selectively moving just one of the items, but not the others.
Yeah, but you are not able every time to choose the target. That's one of the points we could discuss later. And in this one, I just use a rough quick of some examples so you can see what I was speaking about later. So for example, we took this one, which is heavier. You saw it's about 2.4 grams, and it's very, very difficult to move in a glass jar. And you see, it's a rare example we have. So you see the end are out of the space. There is no hand. And it's success to do that, but you will see that better, but it's very slow. Look at, sorry. Yeah, you can see that it's moving, but it's very slow. Okay, so, yeah, maybe you can see.
Yep, I mean, these are all really interesting and quite impressive examples of telekinesis.
This is moving better. Okay, this is moving better. You can see it. Yeah. It's very slow, but it's running. So this is my first example, just to put the plate in place. I will come back to my presentation. So if we make complete physical isolation of the target system, we have clearly a phenomenal inhibition. As you saw on my example, even if we were able to run this target, it was a very light target. So as I show you before, it was maybe some tenths of gram. Okay, And when we try to use a bigger target, we saw it's very slow. And we use double glass jar. We use also with Faraday grid, and it works. And we use also with vacuum. So we use a vacuum sucker of air. And so we are able to move the target even if we suck a part of the air. But it's not, we didn't move so far on this example because we did not measure really what the pressure, residual pressure was in the glass jar. But we showed that even if we decrease the pressure of the air, it was working again. So what we are saying is we are looking at people who have already talked about this before, and Jan and June, which were the peer laboratory close to Princeton, they put in place, they already say that uncertainty and fewer constraints may be a prerequisite to have larger phenomena. And so it's taking important into account. And if we look to Puthoff and Targ, which make some experiment with Ingo Swan with a superconducting differential magnetometer. I just read the phrase because it's better, I think. They say the subject thus appear to act as a local negentropic source. If true, it may be more advantageous as practical matter to work with extremely noisy systems rather than with highly constrained or organized systems in order to maximize possible effect due to the introduction of order. So I think it's interesting. This phrase is maybe from 50 years ago, but it gives some very interesting content and a hypothesis on how the systems could maybe work. And on our side, because of our experiment, we decide to use partial physical isolation systems. So we lower the physical perturbation. For example, we're using a cabinet, or we're using a portable system which is partially confined, and we put some measurement outside to be sure that we are able to measure the remaining systems, and so to be able to compute the ratio between anomalous perturbation that we discover and over the normal physical perturbation. So if this ratio is above 1 plus the error ratio, we normally have a phenomenon. And we'll see after that we have a ratio and some time which is about 10. So let's come back to the phenomenon. So if we took this target, we already see there is some mechanical, magnetic, electrostatics, aerodynamics, force possible, which implies the movement, triggers the motion of the systems. So if we look to mechanical vibration, we did some experiments. Let's see. Okay. So for example, we use sound generation. Accelerometer to see the strongness of the acceleration, and we try to change the sound. I don't know if you hear the sound. David, do you hear the sound? David?
Yes. Oh yes, we definitely hear the sound.
Okay, fine. I wanted to be sure. And so we tried to have different levels, and we saw that in fact we were not able to really move the target in a steady way by vibration. So we try also about
Eric, we can't hear you talking over that sound.
Okay. Sorry.
Okay.
So I just said that in this phenomenon. No, this is the magnetism. I come back here. On this, we were not able to make a steady motion of the target using the vibration. Okay, so it's not the mechanical vibration which is at the source of the movement of the systems. So we work also on the magnetism. Magnetism, it's pretty straightforward because as it's plastical, you can see here, as it's plastics, you don't move with a magnet, okay? So that's pretty evident. And we use also electrostatics, which is less evident because in this experience, so I will talk before launching, we use a static generator, so it generates charge, and then you approach the end and you will see what happens. So you see the little paper which is attractive, okay? And when you put your hand and you look at this, you follow the target, so I follow the target. You see the target is running. It may half turn and then stop and come back. So in fact, with static charge, if you don't move your hand, you can't make more than a half turn. So our approach is to say that we validate an experiment if we make at least one turn, one steady turn. And in fact, we make many experiments where the target is driving during 4 minutes. But that's important because when you make some test or you see some video on the net, if you use your hand and you follow the mobile, you can run the mobile, but you have to move your hand around. And it's static effect. So you have to be careful about this.
Eric,
let's come back.
Just to recap there, because there's some really interesting points it's worth just emphasizing. So you tested vibration, sound, and magnetism, and none of those had any effect.
Yeah.
But the electrostatic did, but you would have to move, in a sense, you'd have to continuously move your hand with the mobile.
Yeah, I can show, because you asked, I can show you this. I didn't, this time we used to move the hand. You see? So you attract with the hand. Up.
Yeah.
Okay.
Yeah.
Always follow. So some video on internet, it's really static effect.
So yeah, that's an electrostatic effect.
Yeah, exactly.
But as you say,
but
what you're looking for is...
Yeah, if you don't move your hand, if you stay your hand at the same place, you can generate more than a half turn. Because of the static, the charge change after half turn, and so it's come back. Okay?
Okay, that's good.
So it's why it's very important to, if you look at movement, to be sure that it's not static effect, but you just have to be sure that the target is making at least one turn. Okay? And our approach is to launch and have a steady run, in fact. Steady run of the target. So, in fact, what is remaining, it's airflows. So either thermally induced air current, so by the hand, because your hand is hot compared to the temperature of the air around. Either it's because you make some deviation of a current, existing air current in the room. And in fact, the most often is this later, is the last time. And we'll see why. So we make some computation to see what is the impact of a hand of 37 degrees or more, but normally it's around 37 degrees. And in fact, you can simulate the hand by what we call a vertical heating plate vertical. And after you make the computation, you are able to see what is the speed of the air along the hand. And here, if you take some distance from the end, like here, if I move here, what is the speed? If I move here, what is the speed? And if I move here, what is the speed? So this is exactly what you see here. So if we make just a synthesis, you could see that the max speed is around 5 millimeters from the end. And at 10 millimeters, there is close no effect. and the speed is bigger at the top, surely, because it accelerates here and move up. So that's the effect of one hand. Okay. So if you put your hand, we make the experiment. If you put your hand below what you could call a wind turbine, you know, it's a blade, some blade. So we take aluminum paper, we make some blade, and you put your hand below. So the air, because of the heat, the air current is moving up, and the turbine is running. Okay, and if you put your hand just close, so in order to be like this, you put your hand here and you put the turbine close here, you are able to move also the turbine. But if you move away 1 or 2 centimeters away from the turbine, you will have the difficulty to use your hand to turn it. Okay? So that's important, because if you look to some small, some light object, you can run like this. If there are some, it appears it's cool like blade. And so, but if you use the same approach on this, for example, which is 10 grams, there is no move. It's too heavier. And if you use on this, where there is no blade, same thing. You can't move it with just the air current moving from the end. And also, we just try. So you just, in your arm, you can take a frying pan, and we take our target on a cork plug, so it will not fry with it. And we move the temperature until, as you see, 120 degrees. And we were succeeding to make some little movement. For example, I will show you up here at 85 degrees. You can see that we have some small movement of the target. But we are at 85 degrees, not at 37, and it's small movement. It's not a steady run. Okay. So let's come back to, okay. And we also make some artifact test. We use a glove with hot water, and we put the glove along our target, and we did not success to have move. Target, you see, not at one centimeter. So, in order to have a more scientific approach, we decide to, in fact, try to measure the airspeed around the target. So the difficulty is because it's slow movement, you can just use an anemometer and put it, because the anemometer don't move with this slow movement. We are speaking about something like 20 centimeters per 20 millimeters per second, 20, 30 millimeters. I will see the further one. So how it works, we use some fog machine, the same you can use in a nightclub or in concert. And so it generates smoke, particular smoke, and we eliminate this particular smoke with a laser beam. And so because this particular smoke are eliminated, you are able to see them through camera. And because this particular smoke are very light, they follow the air current. So the fact you see the smoke and the particular smoke, you see in fact the air current. That's our approach. And it's called PIV, like particle image velocimetry. That's the technique. So the idea is to use, as we say, partial isolated systems. So we use it's like a phone booth, with a curtain. So there is not too much air current around, because you go inside the box here. You have the table and you have the target. We put the laser here, and we have the camera above. And so the camera is, the camera is here. So the camera is seeing the target, the hand, and the flow, in fact, the smoke particles eliminated by the laser, and so you can see the flow. So the next step is, and we take camera, we take film with 50 images per second, and so and each image, we make image computing to identify the small particle or the aggregate of small particle as pattern. And between two images, we calculate the distance covered by this pattern. And so we are able to, because between two images, if you are at 50 images per second, it's 20 milliseconds between two images. So you are able to calculate the speed of the particle. And so you are able to calculate the speed of the flow. And we represent this speed by some vector. So in fact, here we have the flow. You can see, and here it's vectors representing the speed. So the speed, we take this point, and the speed at this point is this vector. And bigger is the vector, bigger is the speed. So first we do experiments with three parts. First part, it was used here. You have a pump mixing smoke and air and pushing it in a hose which is moving on the target. So in fact, we drive the target with airflow. Second experiment, we take electric motors with a flattened needle, so he is able to drive the plastic cup here. So the plastic is moving and the air is moving because the plastic is running. Okay. And here, the last steps is the telekinesis test, where we have a hand. So the telekinesis puts his hand, you have the mobile, and you try to move the mobile. And we, as a comparison, we make the ratio between the dome speed, so the plastic cup speed, and the periphery airflow speed, so the speed around. So what happens? We make 10 experiments. If we look to the ratio here, so the ratio is again, it's the speed of the mobile divided by the speed of the airflow. Here, when we move the target with an airflow, with the pump, the mobile is going less quicker than the airflow because we have a loss of energy. Okay, so the ratio, we find the three experiments here. When we use a motor, it's a motor which is driving the air. So the motor, the target is going quicker. So the ratio is above 1, and we find the experiment here. And for the telekinesis experiment, the question is where we are. And in fact, we are here with one which is between 2 and 7 ratio. So it proves that in the T experiment, it's not the airflow which is driving the cup, because the ratio is above 1. Okay, and it's more, we are close to a motor, but it's not an electric motor. In fact, it's maybe a telekinesis motor. So that was the first experiment, and we published some paper in a SSE, in a journal of scientific exploration about that. And then we make a new experiment. The objective to say that because in the precedent experiment, the target was already moving, and we were looking the ratio between the speed of the target and the speed of the airflow during the movement. And the idea here is to say, if we start the mobile, if we need to start the mobile with airflow, what is the threshold? What is the minimal speed of airflow that we need to start the target? And compare it to the speed we need to start with a PKR experiment. And so in the same time, we wanted to improve the signal to noise ratio, because the smoke generation is always something which gives some noise, and also a better confinement, and also use a portable bench, because we think that it's very important that if people can take that at home, they can make many experiments, and it's very good for the mood factor, which was something which was putting in phase in some other paper. And also we can multiply the experiment, because people are that at home and they don't have to go to the labo to make the experiment. And also we wanted to answer to some explanation which was given in the past. For example, the Nekayev explanation, he said that for this small paper, because you have a difference of temperature between the palm and the fingertip, the current here is faster than this one, and so it creates a disequilibrium, and so the paper is running. So that was one explanation. The other was one from Varcollier. So we are above the system here, and he says that because the body heat, the upper body of the telekinesis create upstream, and then this upstream draw the air along the table, like an horizontal air current. And because you put an obstacle, you make a disequilibrium between this place, this part, and this part in the air current, and so the mobile is running. And the last one is Andre Hoffman. He says that at the wrist and also on the end, you have the pulse, the blood pulse, and so this blood pulse can generate some phonic pulse wave that move the target. So in fact, using our new system, first we use a heavier target. We put 3 plastic cups in line, so it's really more difficult, there is more inertia to run it. And we use this portable bench. So you have it's a plexiglass box, sorry, with a lid, plastic lids. Here there is an opening, so you can see the target here, and there is a camera, and here is the laser, which is able to either make a slice, horizontal slice, or vertical slice. We can change the slides, and we generate the smoke with 2 incense sticks, so it's very smooth. It's not a pump generating something. So, as we say, we have less noise in the systems. And the way it works, the telekinesis put is in here, the target is here, the opening is here, and so you see that the hand is above the target. So it answers all the questions before, because if the hand is above the target, all these explanations are not working, because I'm not making obstacle to the target, because I am above. It's not because there is different temperature close to the object, and also it's not because there is a pulse, a blood pulse at the end, because my hand is above. So it was a way to answer all this explanation. And this time we make 2 experiments. We use the old bench, so what we call the static bench, to make some reference experiments, so to try to see what is the threshold of airflow speed in order to try to success in starting the target spin, so trigger the motion. And we focus on the 10 first seconds of the movement. And we did the same thing on the portable bench. So this was in Poitiers in France, and this was at Montpellier. And we use the same thing, so compare the 10 seconds. And so what happens? We use 2 parameters to compare. The first parameter is what we call here. In fact, you have the vector here. In fact, are the mean airflow speed during the 10 first seconds of movement. So it represents, in fact, 500 image. So 500 calculation of the mean of the 500 vectors of each difference between image. Not sure if I'm clear, but to study this, it's the mean vector airflow during the 10 seconds. And we use this rectangular oblong area to define the global average speed on this place. And here, so this is the first parameter we use, and the second parameter is we take the tangential component of the speed using a 30-centric cycle, and we try to see the evolution of the tangential speed in function of the distance from the surface. Okay, so evolution of the tangential speed when you move out radially from the surface. And so when we make this this comparison. So here we have the two experiments which are made with generating airflow with a pump. And these are the two experiments which are done with a telekinesis. As you can see, first, the vectors are, and it's the same scale, sure. The vectors are very different here and here. Here we have 31 millimeter per second as a minimum average speed. And here we have 2.4. And here we have 23. So the lowest is 23 millimeter per second in the two experiments. And here we have between 2.4, 2.7. So we are close to 2.5. So it's close to a line ratio between the two. And if we look to the tangential speed, so the speed, the tangential component of the speed along the circle, you can see that here it's the two experiments with airflow generated by a pump. We have two experiments with telekinesis, and we add two other experiments, one with the hand, but without any motion. So the hand is on the portable bench, but there is no motion. No motion would trigger. And another one when there is no hand at all. And you can see that these curves are very close. So you put a hand or not, you don't make a big change on the airflow inside the box. But if you use, you have to start the target with a pump, you have to use this speed. And between them, it's around 10 ratio. And I can show maybe after. Yeah, maybe after. Oh yeah, it's not good. Okay, let me see. Okay, so the other point that can people say is that, but okay, you make a slice, an horizontal slice, but what happens on the other slice? So that's a very good point, because you can say, yes, maybe at this space it's like that, but if I take an horizontal slice 1 centimeter above, it's different. So if we calculate, we use Reynolds analysis, and we use some standard numbers, and we see that our numbers is max at 973 compared to 2,400 if we have a turbulent flow. So we are not in a turbulent flow. So what happens in an horizontal plane is close to what happens to another horizontal plane. But just to be sure, we make also a vertical speed analysis. So we put the vertical slice of the laser here, and we measure we make the same analysis to the speed on a vertical approach. And you can find that we found 2.7 and 3.2 millimeter per second, which is, sorry, which is very close to the speed we found here. So the speed in the horizontal speed and in the vertical speed are close, and there is no difference. And just to show you effectively what it look like. So here you have the airflow generated by a pump, and here it's airflow, it's the experience with a telekinesis. And just compare the speed. If we have an airflow with a speed lower, it doesn't start. So it's really the threshold. And here, if you look at the speed of the running here, you can show on the two sides, it's really quicker. Now you have you can see here sorry, maybe I take too much time on that. I have to move on. So, and the last experiment we've done is we use a complete artifact experiment. So we use glasses with hot water in order to simulate the hand. So you have the target, it's the hand, and you simulate the wrist. And here we simulate the upper body with a glass jar full of water too. And we just try to start the target, and we were not able to start the target. So in fact, the known force don't explain this movement. and we think that we have a potential macro PK. We have evaluated the energy. So in the experiment, you just see it's around 1 microjoule. But in the experiment of the double mold, for example, and the very speed run you saw at the beginning, it's around 20 microjoule. So we think that it's important between the micro PK, which is a random number of generators, we have many work, and between what we are working also on the poltergeist and mediumships, where we are more on the spontaneous case, where there is very big macro PK. There is a space to work on when we have some semi-repeatable physical effects. We are able really to make experiments. We are in the range of 1 to 100 micronewton, so it's really less than here. But even it's 10 or 1 or 10 microjoule, you can't explain this movement. So I think it's important to continue to search on this. And our portable bench is very useful, and it can be used by other lab too. So just to finish the conclusion, on our side, we are working on the intention impact. So are we able to imply a direction of the spin at start? Are we able to start are we able to start it when we want and stop it when we want? The distance impact, we have already made many works on it, and we find that when we move at most that 40, 50 centimeters from the target, the target of 2 grams, it's difficult. And the confinement impact, that's very important characteristic we have to work in. And also the vacuum impact, so making further research with more vacuum and so forth. So thank you very much for your attention. I will stop the sharing to go to the Q&A session.
Excellent stuff. Thank you very much for a really interesting presentation. There's a lot wrapped up in that. I've put a reference on the chat window to Eric's paper on this as well, because one of the things that always comes up is this notion of airflow, and the key point there in a lot of those experiments is that look at the physics. In order to get the mobile moving, the airflow needs to be faster than the mobile to get moving, and what he's showing there is that it's not. When these TKers or the PKers, however you want to define them, it's the airflow is much slower. So there's something else that's moving those mobiles. And I have one here, which I'll show you, which Eric very kindly gave me a whole set of these back in 2018, and I give them to my students every year. And in the class, we try to get them to have a go. I was going to say, whilst we're chatting, I'm going to put this on my desk. You can show this down here, be on my desk. So what I'm going to say is, whilst we're sort of chatting over the questions, once I can balance this back on, there you go. So it's there. Okay, you can see it. Oh, it's moving now, but that's probably just vibration. But perhaps we can all send our intention to that, see if see if we can get it moving. Okay, Eric. So for some reason I can't quite see you. I think it's your background. You've got one of these weird background things.
That's surprising. I'm not there. I just make it invisible, That's
exactly. I can see your box. Okay, so let me start with a couple of questions from the board. Thanks very much, everybody. Duncan, this is a really interesting question. So he's saying, do you have any specific techniques or tips, advice, if people want to try this at home?
I'm just trying to coming back. Sorry. Anyway, I will answer. So yeah, some specific. First, you have to be sure that you are not too much in an air current. So that because in fact, as I say, it's a more classic approach. And I think even Varcoli, I show you, I think it's the problem were more air current than heat. So try to use that in a room where there is not too much air running. Also, you have to take that like fun, and all body say that. And maybe sometimes it's good to not too much focus on saying, is it real or not real? Don't just play. Because sometimes, when we work with more different people who just try, because they just try. Sometimes I know it's air current, but I don't say it because people are trying, and sometimes, oh, it happens something different, you know. And because they are in the positive mood, they move along, and finally the success. So you have to try, and you try with small lights at start, light target, but maybe not too light, because with the aluminum paper, you know, it's always a bit tricky. And also with the egg wheel, try the egg wheel, but with the end a large from. But the problem with the egg wheel is it takes easily the air current. So and I think you have to try different objects, you know, you have to feel it. And if you are in a good mood, and just try, but you have some time to be patient.
Yeah. So keeping a positive mood, and keeping it or maintaining an element of fun as well.
Yeah.
There's things there, having a go. You know, having a go at these things. So a question I have there then is, and it links to Christoph is also sort of asking this question. It's linked. So your TKers, your participants, are these people are these gifted individuals? Are they gifted psychics? Are they mediums? I mean, where do you find these people?
I find people are working, you know, through the internet. We work like this, and people know about us, and sometimes they just send an email and say, currently I have some American guy who would say, oh, I saw your article, bye-bye, I'm interested because you are making some scientific approach. Well, I am doing that, and they send me some videos. And what do you think? I say, just to try to take our plastic cup and try it, and we can go on, and we can, and then so the question is there gift people? Sure. If you look to what we use as portable bench, the last one with the hand is above, it's Carl, which Carl is very good. So, and also the mold, the double mold is Carl. So it's pretty gift people about that. So it's not like a mediumship in trance, okay? But it's people who have trained themselves and have some good capacity to do that. And so we have some like that, and some work with us during a time, and after they have, you know, they have their own way. They stopped, and sometimes they come back 2 or 3 years after, and we have so. But yes, but you can try. Maybe you will able to move some, and maybe you can't move the double mold, but that's okay.
So in a sense, you sort of selectively recruit these people. Well, to some extent, you get them, you test them with your box initially, and if they are able to produce something, then you bring them back to test them again and get. And so one of the questions I have then is, what training do these people, do they spend a certain number of hours a day or a week trying to do this? Is it something that takes a long time to learn to do?
Yeah, I will come back a little bit. I think that we have two things. People, when they come, they very often have already tried something. They say, oh, I'm making some success on this, and what do you think? So what we want, it's first, even if they continue to work with different objects, very fun, they try to work with our standard target. So we are able to evaluate. And then after, they can send videos, and we see how it works. But I would say that the portable bench, we don't ask people to do that, because from start. In fact, it's you know, you have to be trained, and it's more difficult, and not all people are able to do that.
Okay, so Barry's got a very interesting question, and it sort of links to this as well, because he's saying, have you had any magicians review your apparatus and controls? You know, because you could imagine a situation whereby, you know, somebody, I mean, I don't know much about magicians, but you could imagine somebody saying, oh, I can do this, I can move mobiles by thought, and they may be, you know, doing this with some other
you have many crank on the internet, you know.
Many interesting and varied individuals, I think what we
Yeah.
meant to say there.
Yeah, but you know, the fact is that because we wanted to have a scientific approach on part of it, our portable bench is a very good tool, because if you make some mouse movement, or if you put your hand or something, we already see directly with the flow.
Yeah,
it's a very good against trickery. I have a slide for that there, somewhere here. Oops. Oh, what's happening?
we've lost your picture, Eric. Oh,
yeah.
we've lost your picture there.
I will come back here. Maybe.
Okay.
No
What's your
great
sort of-
loss, I think.
Well, yes.
Yeah,
Well, no, it's nice
You
to
don't
see
have
you.
to
It's
see-
just, it's very difficult to see you because you've got one of these weird backgrounds. And I think what it does is the minute you move, the background fills in and it's continuously
I
overfilling.
understand.
So, you know, it's the
Sorry.
background. That's better. Yay, that's better.
Sorry. I did the same because we make this, you make the stair at the end of the day.
Yeah.
So I start with the normal light, and when I'm in the conference, I forgot that there is no light in the room.
Yeah.
So now I'm sorry. So
No,
I'm
that's
back.
okay. I have another question about, because when you were talking about all the different types of mobile that you had people move from, one of these to three, and that big long looked like a tin.
Yeah.
Is there your participants? Do they say that it takes more effort? Is it more effort to move a larger object? Do you see this sort of effort trait, this sort of linear effect as you would expect if you are physically moving an object?
No, exactly. You're right. So always we always try to think maybe it's in our head. So the difficult thing is to say maybe it's a psychological barrier we give ourselves. But now we have done that for many years. Clearly there is it's more difficult to move a heavier object, And if you look to some result in the poltergeist area, they find also that you can show that normally objects that are far from the guy are moving less, and so there is some decreased strength. And the other point that you mentioned, and is very important, is the train curve. And for me, the fact that there is a train curve, it's already a proof that there is something. If there is no train curve, there is nothing to train. So the fact, and when there is a new object, you have to work on it, because at first it doesn't work, and it takes time to go on. And I remember Carl working on the porcelain. He saw the porcelain ball and 40 grams, and it started at the beginning, and after he was able to run it very fast, but at start it don't move, not so much.
How long did it take him before he could get that porcelain bowl to move?
Sometimes I remember sometimes it could take months.
Now I think that's
Depends.
But I think that just absolutely flags up a key factor, because, and this is something I've found when I've tried to recruit and run PK studies, experiments, is the level of training that's required. Most people will think, oh, this is fun, I'll give it a go. And within about 5 minutes, they're bored, basically. You just think, I know it's hard to keep, I'm not sure how much fun you can have just trying to sort of spin this mobile around. It's sort of fun, but it doesn't last very long. Perhaps what you need to do is create an app for people's phones. So that's completely random. And then what they do is they get it to spin one way or the other, or something like that, and get the kids training on this stuff. And maybe that's what one thing to do. Because
and I just want to complement this. Also, when you stop, if you stop to do it during 6 months, 1 year, and you come back, it's not like you ride a bicycle. you come back, and it's not so easy. You have to retrain, and so.
Does that mean there's a cumulative effect in the training, in the sense that as you train and you continue to train, people tend to get better and better at it?
Yeah, but it looks like sometimes we have a threshold. So people are not moving up bigger and bigger. And also when you stop, you lose a part of the thing and you have to retrain again.
And do you ask your participants what they're thinking of when they're doing this? Are they trying to send, is it something about energy coming out of their hands? Are they just visualizing the mobile moving? What is it that they're doing? What are they thinking of? What are they thinking of?
I will give the answer. For example, remember the first video I show you?
Yep.
Where the target is running very fast?
Yeah.
It was Pierre in Canada. He say, when you speak about intention, I just put my hand and that's it. And sometimes it did. And sometimes it did not work. Today, for example, I try and it don't work, and tomorrow it works.
Almost a sort of unconscious process.
But there is a training. Even him, there is a training process. But for him, there is no intention. But you say, saying that you have no intention is very difficult, because how do you know you have no intention?
Yeah. Well, perhaps the intention is, but it's almost as if you put your conscious sort of thinking, critical mind to one side and just allow something to happen or not.
And very often, in fact, sometimes when you concentrate very much strongly, and it's just when you let go that it starts. And it's known. It's a known effect. I work with Jean-Pierre Girard, who is making metal bending. Very often he makes these things, and that's not working. Just start to stop, and the system the metal is bending. So I think it's really tricky. And so I think that very often I say, yes, I have found the good mental key, the mental step I have to do in order to do that. And when I think I found it, I try the next day and it didn't work. So I think we can't make a conclusion. Some people are speaking of energy. Some people say that I'm just doing that. Some people are visualizing. On my side, I really look at visualization. I try to see the system spinning, and very often in your hand, in your brain, you start to the system is starting running alone by themselves in the brain, and very often it starts after. But it's not systematic, so I can't say you have to do that and you have to visualize. Blah, blah, blah.
And it may well be that different people, different procedures, different approaches work better for different people. So another question. Another question I have, because to me, if we take the view that this is PK, and for me, that's something about conscious intention. There's something there about conscious intention. Why do we need to put the hand near the item? Why can we not just use conscious intention?
Yeah, as I mentioned, when you put your hand, I'm able, sometimes I make some video with multi-camera, I'm able to start the target at some 45-50 millimeters, but I need the hand. But for example, the one you see when the plastic cup was running under a glass jar, very slowly. The guy was doing that without his hand. And we are trying today, because we are trying to, for example, to put the hand very far. But maybe it's a mindset. The problem is the mindset.
Yeah.
And so we never know if it's required or it's because of your mindset.
Have you tried it with children?
Yeah, in fact, sometimes we make some kids parties, some take-up parties, and we just have new people coming, and some are really good. It depends.
Because
they have no barrier,
Yeah, and also there's an innate element of fun when they do it, which often adults, don't have.
And the good way to do that, you invite people, and you don't say anything. You just put the plastic cup, and you say, let's play, trying to run it, but without the end. So
there you go.
So maybe don't put the end, and sometimes a very strong result. And I remember once at home, I have one of my family, he was trying, and it was working so fine that I get my glass jar from my lab, my personal lab, I put the little and they try, and it works. It was fun. You never know what happens, and people are sometimes very strong. And also they're really strong the first time, and they don't success after.
Yeah, well, that's
and they have to train.
Yeah, well, that's because initially it's like almost an unconscious response. You don't give it much thought, and then of course the cognitive processes start to kick in the self-doubt and the internal dialogue and everything else. So your participants, all the ones that we've seen there in your really interesting presentation, they're all individuals. Do you ever do this with a group of participants working together? So one would sort of maybe assume, I mean, it's a big assumption, but maybe with a group of people, the effect would be stronger, sort of, you're doubling the output as well, or tripling if you have more than
in fact, we make some what we call TK parties when we are 4 or 5 guys working, but in fact, what happens, each people come with their own target, and they try to work together, but they don't. When we try to work on one target, we didn't see so much, but we see a very interesting effect of the TK party on my side, because when I start to work with people, and I was not able to drive the target under a jar, glass jar, and I met with people who were able to do that, and in fact, it drives me. It's incredible, and when I come back to home, it happens something very, very fun. For me, it's like the magic. Maybe I can show you, because it's so fun.
Sure.
You want to see that?
Yep.
Let's
I most certainly do.
Okay. Up. So I come back to the screen. 2, 1. Go. Okay, it works. So let's try to see this one, I think. Confine. So I will give you the story of that. It's too incredible. You see my screen?
Yep.
Okay. So this is my home, and there is my glass jar with three targets.
Yep, 3 targets.
Okay. And I tried. It was just some days after a TK party. In fact, I tried the day before, and they seem to work alone. And maybe I say because there are big storms, the influence, geomagnetic influence, the mental is always working, and asking questions. And so the next day, it was a nice day, no thunder. And I do the same thing. And in fact, the phone were running. At the beginning, I put my hand, and after I moved back, and they were running. And then I move really back. So you see, I will show you when I go back. I was there, It just make the zoom, but I was at 2 or 3 meters. And then it didn't stop. So I decided,
Do you think, though, straight away I'm looking at that room setup and thinking, could it be sunlight coming through the window, heating the air up underneath the jar, causing some thermal reaction?
That's always a question you say, but if you try to do that, you see that it's not so easy, and why the third is not working. And also because it's the same area that I use all the time, and I'm never able to reproduce that, Oh, wow. And you see, I stopped, and I put my stand for the camera, and I get out of the room, and the system is continue running. So I get out of the room. I think this is on the camera now. And then I came back, you have six minutes. You don't have the sound.
Yeah, and that one.
And I came back, they are still running.
Yeah.
And I have to stop that.
Interesting.
It was 9 minutes, Incredible. And there is no big sun, you can see that it's the light.
Very nice. Okay.
So that's happened once, like that. I never have it again. So I will quit it.
Okay.
But that's part of the life.
Yeah, I have one last question for you, Eric. Oh, we've lost your picture again.
Yeah,
oh, that's okay. You're back. So I have one last question from Duncan, which is, do you have any theories for perhaps an evolutionary origin or benefit for these abilities, or a way of accounting for them?
Yeah. For me, you know what? Right? It's why I'm working strongly around poltergeist and all this phenomenon. I want to know exactly what is happening in the detail before I want to put any hypothesis or theory on it. Because if I make that too early, I will stop the case. So I'm not finished yet on the poltergeist and mediumship, and also I also make a study on the mystics levitation. And once I will make my round of that, I think I will make some hypothesis on this. But it's an impact. It's a direct impact on our view of the reality. It's normal.
Yeah.
It's universe and consciousness. And I think if we go too quickly on the conclusion, we miss the fact.
Absolutely. Well, I would argue consciousness is fundamental. Well, as many others have argued as well. And I note from your presentation as well that, as you're going, because this is research that you're carrying forwards, that you're taking this forwards to start asking those questions, such as, can you increase the distance? Can you do it with hands? Can you switch? Can you sort of alternate between, spinning left, spinning right, stop, in a sense, gain more control over the movements, I suppose, which would answer a lot of the critiques.
And that's exactly the work we are doing with two gift people about the intention. So, put generators, and so you have to start at what time with, a smartphone generators, give the time, beep, you have to start. Yes, you have to stop. And then you have to change, you use a generator to say in which side you go. And so we are working on that, but it takes time. Also, people have to be available. They can do that, and blah blah blah. And you have to put the protocol. You know that, huh?
I do. But all of those things. But what I was going to say is that, because that sounds really interesting, so I'm going to sort of lowball you and say, when you get some results on that, perhaps you can come back and tell us what you find.
Yeah, I would be happy to do that.
That would be excellent. Okay, so let me just check. Did I have a couple? So there's a couple more questions. Okay, so quickly.
No problem.
Well, so this is from Lynn. During adolescence, I used to have telekinetic dreams. Is this a common phenomenon? Do you know? And is there any explanation for it?
I love that. I'm a fan of OBE. I have success to have about 10. And sometimes I have strong lucid dream or dream when I'm imagining that some things are lifting, levitating, and but I don't think I don't see any connection direct. I think it's more because my brain is focused on it, and so I push some dreams on it. I did not make any connection between, yes, I have a dream and tomorrow I success. I don't know if I answer the questions.
That's okay. That's fine. Okay, so let's wrap that up. Thank you very much for staying on, Eric, and talking to us about that. I will carry on practicing with my device. And so I love the idea. Everyone out there, I should ask you again when we meet again in the online PK parties.
All people have to try.
Yes, have a go. Get yourself some of these little plastic containers wherever they're from, and cork with a pin. The great idea, great excuse for a glass of Prosecco or champagne.
French wine.
French. Only the best French champagne.
It works only with French wine.
Oh, that's an excellent one.
No.
Perhaps you could be sponsored by Moet Chandon.
Yeah.
That would be nice. Okay, thank you very much, Eric. Thank you very much. Round of applause. I'm sure everybody is thanking you. Thank you very much for coming along and talking to us about your really interesting research. And for me, it was very interesting as well because there's so little PK work being done, you know, in the lab, as it were, and it was so refreshing to see the work you're doing and the rigor that you're bringing to it as well. So thank you very much for that. Thank you everybody for coming along, listening to us chat. Merci beaucoup, Sheila. Thank you very much. And thank you very much, everybody. Remember, next week we've got Christine Simmons-Moore. If you're interested in taking part in one of my studies, ping me an email using my email address, which is in the chat thing there on the side. And I shall see you all next Monday. So I hope you stay safe and have a very good week. Thank you very much, Eric. Thanks for that.
Bye. Thank you. Thank you, David.
Yeah, that was really